Hello friends, we're going to be going over data analysis and probability. Data analysis is part of a math called statistics. This is a type of math that is taken in college, and depends if you want to take it. It depends on your major. But this is just scratching the surface of statistics. I'm going to begin with discussing data analysis. So, friends, we're going to learn how to collect data effectively. We're going to sort and organize data. We're going to learn about sampling, creating graphs, the measures of center, variability, and how to analyze data. Now, collecting data. So, collecting data effectively is a very important part of learning statistics. That's the key word, effectively. Data can be collected through experiments and observation. This part's so important because without data, there's no way to analyze it. There's no way to put it into graphs. There are two types of data: categorical data, favorite vacations or colors of cars, numerical data such as counting or measuring objects. Well, counting being and measuring objects. So, sorting and attributes. Attributes can be any set of objects that allow items to be sorted and classified into different groups. For example, hair color, height, size, and color. Okay. The one example I have here are gumballs. They have one thing that's the same about them. Gumballs. They're all gumballs. But they have something different. It's their color. So this person sorted these gumballs into colors. So the reds are with the reds, the orange ones are with the orange ones, the blue ones are with the blue ones, the white ones are with the white ones, and so forth. These were sorted by their different attributes and characteristics. Sampling. This is a very, very important part of collecting data for statistics. So, random sampling. I'm going to read off the definition and then I'll give you an explanation. Random sampling. In statistics, a simple random sample is a subset of individuals, chosen from a larger set. Everyone is chosen randomly and entirely by chance, so that each individual has the same probability of being chosen at any stage during the sampling process. So random sampling, a good example of this is presidential polls. When people are voting for the president or any law, but I'll specify and I'll use the presidential polls. What people do is they stand out of any random polling place and ask random people, who did you vote for? And they tell you. And they use this data to kind of be able to predict who will be president next. Obviously there's issues with this because sometimes, one, people don't want to tell you. Two, they lied because they're kind of embarrassed of who they voted for. So this is a very good example of random sampling. You just choose random people and they tell you an answer. And then you try to collect the data of that and try to predict an outcome. This basically, like the epitome of statistics, is predicting an outcome with random numbers. It's interesting. Also, what's very important to sampling is variability. So, the little example I have, because the definition is the lack of consistency or fixed pattern, liability to vary or change. That can be kind of confusing, so I'll use an example. Well, since we're in middle school now, there's not much variation because we're pretty much the same age group, so I'm going to go ahead and talk to you explain this to you with the elementary school, so kindergarten through 5th or 6th grade. So let's say you're trying to figure out the average height of the whole school. There's two ways you could do it. You could go into a classroom, a first grade classroom, and get all their heights. Or you could ask random people, this one goes back to random sampling as well, random people on the playground what their height is. You're in a classroom, the height doesn't vary much because they're all around the same age. And you're going to get probably a much shorter answer to the average height of the school. Whereas if you go to the playground and randomly select, like go to each recess and go to the playground and randomly select people, you're going to get a better idea of what the average height is for that school. So variability is very, very, very important when you're getting your sample sizes. Also the random part too. So this is just a very important part of when you're collecting your data. So you went through sampling, you sampled, you went through sampling, you collected your data, you organized it by its attributes. Now you need to show your data, and that's when the graphing comes in. So you create graphs of your data so you can show people what you collected. So you look right here, there's a whole bunch of different kind of graphs, and they're kind of like radar graphs, box plot, triangle chart, the scatter plot, the pictograph, but I'm going to mainly focus on the bar chart and the pie chart. The bar chart, basically the y-axis is going to have the number, and the x-axis is going to have the different categories. And what you do is you, basically the number, like the bar grows as the number grows. And then the pie chart, so let's say, is going to compare percentages of the whole class, or whole class, whole population. So I'll give you an example for the pie chart. I gave you guys a quiz on probability and data analysis, and the blue are the people who got an A, the percentage of A people, and then the purple is the percentage of Bs, and the C's are the yellows that got C's, and then D's and F's are right here. This is representing the percentage of the test scores that this class supposedly, I don't know if this is accurate data, but that supposedly our class got after they took the quiz for statistics and data variability and probability. So this is the chart you would use for that. So there's different types of charts. Like I said, mainly we're going to focus on the bar chart and the pie chart. Alright. So the measures of center. That kind of sounds hard, like measures of center. But honestly, it's probably the most straightforward and simple part of data analysis. It's just sets of numbers. And you find the mean, the median, the mode, and the range. So there's nine numbers here, right? First, we're going to find the mean, which is just another word for the average. And how you do that is you add all these numbers and you divide them by 9, and then you get 15. The median, you're going to find the middle value. The first step in doing that is putting them in numerical order. And then to find the middle number, there's 9 numbers in the list, so the middle one will be 9 plus 1. So you add all the numbers, you get all the numbers, you add 1, and you divide that by 2, which equals 10. And you're going to divide that by 2 again. So the fifth number is going to be the middle number, which is 14. And the mode is pretty straightforward. It's the number that appears the most. And that number is 13, because that appears 4 times. The range, you're going to subtract the highest number from the lowest number, and that is 8. And that's how you would find the range. Let me check that real quick. Alright, one moment. Yeah, that's the range. Sorry. For some reason, it didn't look right. I just wanted to double check. Alright, so that's how you would find all that. The hardest part about this is probably adding. Maybe you got your adding wrong, or maybe you counted, like, maybe there was 10, you thought there was 10 numbers. Like, that's where mistakes can happen. But if you memorize these rules, it's pretty straightforward. Alright, and here comes our next part, probability, but my wonderful co-teacher will be explaining that to you. You know about earlier in the week I asked you guys your favorite lunches? Now, I just wasn't being weird and asking you about your favorite lunches. I actually had a little activity that I have for you. So we're going to make our own bar graphs. So I categorized it. Many of you guys said candy and you said cake and pie. So I just made that into a category of candy / desserts. The main ones were pasta, hot dogs, sandwiches, tacos, pasta, and candy. So 10 people said hot dogs. No, scratch that. Pizza. 8 people said hot dogs. 3 people said sandwiches. 5 people said tacos. 3 people said pasta. And 3 people said candy and dessert. So you see, this is a different kind of graph, but I'm gonna go ahead and change the color. Let's choose yellow. Nice and bright. So I'm gonna go ahead and put graph data. And look it. This is our bar graph. So right here you see 10 people liked pizza. 8 people liked hot dogs. And what's number 3 people like sandwiches. 5 people like tacos. So do you see how you could visually see the data? It's a lot easier. You look at the numbers. Yeah, you could tell 10's the biggest number, but visually you could just, I can ask you which lunch was like the most. You're gonna be able to tell me pizza. Which is the second best? Hot dogs. What's the least? The least is pasta and candy. It's tie. So this is, once you get your data, you could input it and make your own graphs. Now, if you had a piece of paper, you could do the same thing, but this is a virtual way. Shortor.org to make your own little bar graphs and your own data. So that's our own data. Now let's look at, there's even more categories. See, there's experimental results and the coin costs. See, here's the data that they put the heads and tails, and it shows you that with their data, they got they got tails more often. So that is the end, and I really hope you enjoy the rest of our presentation on probability. And once you hear the probability part, this part will make a lot more sense. Have a good day.